Good morning. Myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about input-output organization. At the end of this video, the student will gain knowledge regarding what is input-output subsystem, how the input-output subsystem can interact with the CPU, what are various categories of peripheral devices. The basic agenda of this video is the introduction, peripheral devices, input-output interface, memory mapped I/O and isolated I/O, and IOP. From the functional units of the computer, there are basically three major functional units of the computer. One is the input unit, the second one is CPU, third one is output unit. The CPU can have an interaction with the outside world with the help of input-output devices. The input-output devices together is referred as peripheral devices. Basically, the computer can work on the principle of GIGO, that is garbage in and garbage out. So, if you are given the garbage as input for the program, the functionality of the program could not be attained, so that the output can be a garbage. So, there is a caution has to be taken to give the proper input to the program so that the required functionality can be achieved. So, the input unit and output unit provides the interaction to the computer with the user, so that here the input unit provide man-to-machine communication. So, if the user want to give any input or the required data for the program to execute, with the help of the input unit only. The input unit receives the required data from the user, convert into the computer readable form and supplies to the CPU. So, the input unit accepts data in human readable form, convert it to the machine readable form and sends it to the CPU. Output unit provides for machine to man communication. So, it receives the information that is generated from the CPU and it has to be presented in the user understandable form. The I/O subsystem of a computer provides an efficient mode of communication between the central system and the outside environment. So, with the help of these input-output devices, man-to-machine interaction, machine-to-man interaction can be provided. So, the needed data for the program execution can be supplied. Whatever information that is produced from the program can be represented in an user understandable form with the help of these devices. So, the I/O subsystem of a computer provides an efficient mode of communication between the central system and the outside environment. It handles all the input-output operations of the computer system. For a program to provide the required functionality, the program required data can be supplied as input. Whatever functionality or the information generated from the program can be represented in an user understandable form with the output devices. The input-output devices both combinedly can be referred as peripheral devices. So, input or output devices that are connected to the computer are called the peripheral devices. These devices are designed to read information into or out of the memory. So, when the user want to fetch the data or If the user want to perform read operation, the required content from the memory can be fetched, which can be referred as the read operation. When the user want to write data onto the memory, then it can be referred as write operation. So these devices are designed to read information or to write information in the memory unit upon issuing commands by the CPU and are considered to be as a part of computer system. So these devices are referred as peripheral devices. Examples are keyboard, display units and printers are the commonly used peripheral devices. So how these peripheral devices are connected with the CPU. So this is the central processing unit and this is the memory. In the memory, so the data can be written and the data can be fetched. So two operations, read and write operation, can be performed on the memory. So here with the help of these input devices, these are the category of the input devices. And these devices can be used to perform the input operation. So the required data for the program execution can be supplied with the help of input devices. So the required input devices are the keyboard, mouse, and also other input devices. Various other input devices are there: MICR, OCR, OMR, barcode reader, joystick. All these are various categories of input devices. Depending upon the application of the user, one or more input devices are connected to the computer, and the produced information from the CPU can be represented in the user understandable form with the help of output devices. Various output devices are monitor, printer, speaker. All these are the various output devices. So both these input devices as well as these output devices combinedly can be referred as the peripheral devices. So here various categories of peripheral devices are available. Majorly three categories of peripheral devices are available. One is input peripheral, second one is output peripheral, third one is input-output peripheral. The input peripherals are generally used allow the user to give input from the outside world to the computer. So the best examples of these input peripherals are keyboard and mouse. Output peripherals allow information output. So the information that is produced as a result of processing can be displayed or can be represented to the user with the help of these output peripherals. So these output peripherals can provide from machine to man interaction, and from the computer to the outside world, the information exchange can be take place with the help of output peripherals. Various examples of these output peripherals are printer, monitor, etc. Some devices can be served for both the purpose of input and output. So those comes under the category of input-output peripherals. So these devices allow both input, that is from outside world to the computer, as well as output, that is from computer to the outside world. The information exchange can be take place. The examples of these input-output peripherals are touch screen. So these are various categories of input-output devices. So these peripheral devices all are the input peripherals and these are the output peripherals. In the input peripherals, majorly we can use the keyboard, mouse and also joystick, light pen, barcode reader or various varieties of the input peripherals. And in the output peripheral category, we are having a printer, monitor, speaker, headphones, all these comes under the category of output peripherals. So these devices in the intersection of input and output can be used as input as well as the output. The best example is the touch screen. So how this information can be represented? That is with the help of ASCII. The alphanumeric characters can be represented with the help of the ASCII code. So input and output devices that communicate with people and computer are involved in the transfer of alphanumeric information to and fro from the devices and the computer. So how this data exchange and this data can be represented means with the help of standard code for alphanumeric characters, that is the ASCII code. ASCII means American Standard Code for Information Interchange. It is internationally a usable code, standard code for alphanumeric characters. So these characters, there are nearly 255 characters, and these characters set is used to represent the 10 decimal digits, 26 alphabets, and a number of special characters like plus, at the rate, etc. So this is the Ascii table or Ascii chart. How this information can be represented. The first set is used to represent the decimal numbers, and here this, if you are observed this is the representation of capital alphabets, and this code is starting from the 65 and can be ended with the 90. And small letters of alphabet can be represented with an ASCII code starting at 97 and it can be ended at 122. So with the help of this standard ASCII code, the decimals, alphabets and special characters can be represented. So what is an interface? Interface is a standard boundary between two separate components of computer system, which are used to attach two or more components to the computer for communication purpose. So generally the interfaces can be CPU interface and IO interface. With the help of IO interface, these peripheral devices are connected to the CPU and can be able to communicate with the CPU. Thereby the exchange of information can be takes place between the CPU and the input-output devices. So what is input-output interface? Peripherals are connected to a computer, need special communication links for interfacing with the CPU. So here in the computer system, there are special hardware component between CPU and peripherals to control and manage the input-output transfer. So these components are called input-output interface units, and they can provide communication links between the processor bus and the peripherals. So these interfaces can provide a method for transferring information between internal system and the input-output devices. How these devices are connected with the CPU with the help of interfaces can be explained with this diagram. So this is the CPU and this is the memory, and this is the system bus. The system bus can consist of three buses. One is address bus, second one is data bus, third one is control bus. The address bus is used to carry the address, memory address, at which location the read and write operation can be taken place in the memory. Next, the second bus is the data bus. The data bus carries the data that can be written or read from the memory. The third bus is the control bus, which carries the control signals to indicate the memory operation. Either it is a read operation or the write operation. Here various categories of input-output devices as well as auxiliary memory devices. So here monitor, keyboard, hard disk are the variety of devices. So those can be connected with a interface and is connected with the communication bus, which is used to carry the information between CPU, memory and the input output devices. So each and every peripheral require an interface which controls and monitors the communication of input output devices with the internal parts of the computer, the CPU and the memory. Why this interface can be needed? So the interface is basically required because peripheral devices are electromechanical devices, or they can be electromagnetic devices. So their operations are different from the electronic devices. So CPU and memory are the electronic devices. So to match these operations between these electromechanical and electromagnetic devices with the electronic devices, a conversion of signal values may be required. For this purpose, the interface can be used. The second need is the data transfer. The speed of transmission of data with the peripheral can be slower than the data transfer rates of the CPU. Why? Because they are electronic devices. The speed of data transfer of CPU is high when compared to the speed of data transfer of the peripherals. To synchronize the speed of these rates, the interface can be required. Not only that, data codes and formats in peripherals different from the word format of the CPU and memory. So here the data exchange between the memory and CPU can be taken place in the word or block format. But these communication of data unit that can be transferred between internally the CPU and memory can be different from the data codes or formats used for the peripheral devices. Next, the operating modes of the peripheral are different from each other and each must have control so that it should not disturb the operations of other peripheral connected to the CPU. So these by using to mitigate these disturbances, the interface can be required. So to synchronize the speed of the CPU with the peripheral devices and to control the basic operations of the CPU and the peripheral devices and to give a standard way of data code and format between the CPU and peripheral devices and to synchronize the operating modes of peripheral devices and CPU, the input-output interface can be required. So how CPU can be communicated with these peripheral devices? So the processor provides a function code in the control lines. So whenever to communicate with the peripheral devices, the CPU places a function code on the control line so that the corresponding peripheral device can be activated and responds to that functional code and proceed to execute. So this function code is generally referred as IO command. There are 4 IO commands. One is the control command, second one is status, third one is output data, fourth one is input data. What is control command? The control command, it is issued to activate the peripheral and to inform it what to do. So here the control command can be used to activate the particular device. For example, consider the magnetic tape. So the control command, whenever activated, the tape rewind and it can ready to execute the IO command. So for this reason, the control command can be used to describe what to do of the particular peripheral device. The second one is status command. It is used to test various status conditions in the interface and the peripheral. It is generally used to acknowledge the transfer of the control of data between the CPU and the peripheral devices. Whether the data is completely transmitted to the memory or not, the status command can be used to indicate the acknowledgement. Next is the data input command. The interface receives an item of data from the peripheral and places it in its buffer register. So, for this, the data input IO command can be used. Next is data output command. The command causes the interface to respond by transferring data from the bus to the one of its registers. So here, to facilitate the write operation from the bus, what is the data that has to be transferred from the bus into one of the registers of the memory. So these are the basic IO commands. So by using these function code, the CPU can communicate with the peripheral devices what operation is to be performed. Next is bus connections. So the CPU and the memory and peripheral devices are connected with the system bus. How these connections can be made? There are three ways that computer buses can be used to communicate with memory and IO. The first one is use two separate buses, one for memory and other for IO devices. So here two separate and individual buses has to be provided for the memory and the IO devices. The second method is use one common bus for both memory and IO but have separate control line for each. The third method of bus connection is use one common bus for memory and IO with common control lines. So three ways are there. The first way is using separate lines for the memory and IO. The second method is using the common bus for the memory and IO. With separate control lines is one method. With common control lines is the other method. So depending upon these bus connections, there are two ways of IO can be available. One is isolated IO. Second one is memory mapped IO. First we will look into what is isolated IO. Isolated IO in which common bus for IO and memory but separate read and write control lines for the IO. So there is a common bus connection for the memory and IO and control lines, separate control lines is for the IO. So CPU decode instruction, then if data is for IO, it places the address in the address line and to set IO read or write control line on to which depending upon that the read and write operation can be occurred between CPU and the IO. As the address space of the memory and IO is isolated, so the name is isolated IO. The address for IO is called the port. So here different read and write instructions for both IO and the memory. So if you observe that this is CPU memory and this is the IO system. So memory control address data lines can be used to connect the CPU and memory. But the control special separate control line can be used to control the IO system. So here the CPU has distinct input and output instructions, isolate memory and IO addresses. Each has its own address space. So this is the isolated IO. Why? Because isolated memory and IO addresses can be used, hence the name isolated IO. So The common bus is for CPU and memory. Separate control line for the I/O system can be used in the isolated memory. Next method is memory mapped I/O. In memory mapped I/O, every bus in common due to which some set of instructions work for memory and I/O. I/O and memory both have same address space, due to which addressing capability of memory become less because some parts is occupied by the I/O. So how the connections are there in the memory mapped I/O. So here CPU is connected directly with the memory and the same address space can be shared with the I/O, the devices itself. That's why the address space, some address space of the memory can be occupied and used by the I/O or peripheral devices. So no specific input-output instructions. Use memory-related instructions for accessing the data. Do not distinguish between memory and I/O addresses. Memory and I/O share the same set of addresses. This is the basic disadvantage of this memory mapped I/O system. Now we can compare and contrast what is isolated I/O and what is memory mapped I/O. In isolated I/O, memory and I/O have separate address spaces. But in case of memory mapped I/O, same address space can be shared by the memory as well as I/O devices. All addresses can be used by the memory itself in case of isolated I/O. Due to addition of I/O, addressable memory become less for the memory. So address space is less for memory in case of memory mapped I/O. And separate instruction control, but here same instruction can be controlled both I/O and memory in case of memory mapped I/O. So these are the basic differences between isolated I/O as well as memory mapped I/O. Now we look into one example of I/O interface. So here the port A, two resistors, the port A resistor, port B resistor, this has to be used to take the I/O data. And the third resistor is the control resistor, which is used to generate the control signals and to perform the read and write operations. The fourth resistor is the status resistor. The status resistor is used to indicate whether the data transfer is completed or it is in place. Next, this bus buffer is used to carry the temporarily store the input and output data. So here this is the timing and control signal, and CS is used for chip select. RS1, RS0 is used for the resistor select. Here set of 4 resistors are there. So 2 lines are used for the resistor select and 2 are the control lines. These are I/O read and I/O write operations in order to initiate the reading process and the writing process. In case of reading process, the content of the memory can be fetched and can be transmitted to the I/O devices. In case of writing operation, the content from the buffer register is transferred to the address of the memory. So this is the configuration of the I/O interface. How it can be work means, so here RS0 and RS1 can be used to select the registers. CS is used for the chip select. If it all chip is selected, if it all 00 is the RS1 RS0, then port A register can be activated. And if it all this value RS1 and RS0 is 01, port B register can be activated. If it all RS1 RS0 is 10, control register, all 1 means status register can be activated. What is input output processor? The input-output processor is a specialized processor which loads and stores data into memory along with execution of I/O instructions. So it is act as an interface between system and the I/O devices. It involves a sequence of events to execute I/O operations and then store the results into the memory. So different peripheral devices are connected to the computer. Those can be monitored and controlled with the help of IOP, input-output processor. So here memory unit, and this is the IOP unit. IOP is connected with various peripheral devices. So in the previous connection, so each device can have an interface. But in case of IOP, input-output processor, the interface can be a one which can be the IOP, which will able to control and monitor all peripheral devices that are connected with the IOP. And how this IOP can be connected? So here printer, magnetic disk, keyboard, various peripheral devices. So these are connected with IO bus with the IOP. This IOP which in turn connected with the system bus, so that the communication with internal parts of computer, the CPU and main memory can be carried out. So thereby IOP can act as an interface and can monitor control all peripheral devices that are connected with the computer. So what are the advantages of this IOP? The IO devices can directly access the main memory without the intervention by the processor in IO processor based systems. So it is used to address the problem that arises in direct memory access method. In direct memory access method, the control can be taken by the DMA controller, and if it all released the bus, then only the communication between peripheral devices and the memory can be taken place. So here to avoid that, the IOP can be used, which can provide the interface between the processor and IO, so that the communication can be synchronized with the CPU and the peripheral devices. So these are the advantages of the IOP. So in this video, I will discuss about the basic concepts regarding input-output organization. So what is various peripheral devices? What is the use of input and output? How the interface can be used? And what are various categories of peripheral devices? What is isolated IO and memory mapped IO? What is the comparison between isolated IO, memory mapped IO, and how IOP can be used? What are the advantages of the IOP? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.